Namaste, future scientists. I'm Ajay Kumar Pandey, your TGT Science teacher from SHRI School, JNV, Jamnagar, Gujarat. So today we're diving into Chapter 1, exploring the investigative world of science, but we're going to do it in a totally different way, through storytelling and investigation. You ready?
All right, let's kick things off with a super simple question, one that might just pop up in your own home, maybe even in your kitchen. Just look at this perfectly puffed up puri. Have you ever wondered, why is one side always thinner than the other? It's a great question, right? And believe it or not, that's exactly where our journey into science really begins.
Exactly. That's it. That's the starting point of all science, just being curious. Whenever you ask questions like why or how, you're already starting to think just like a scientist. And you've got to remember, every single big discovery out there started with just a little bit of curiosity.
Okay, so let's dive into our first section, the question in the kitchen. And just like the title says, science really does begin with wonder. If you think back, in grade 6, we learned that science starts with asking, why? Then in grade 7, we found out that every answer just leads to a new question. Well, now, in grade 8, we're taking the next step. We're going to become investigators ourselves.
That's right. This year, our focus isn't just on learning new facts. Oh no! It's about learning how to find facts for ourselves. We're going to learn how to investigate. What does that mean? It means observing with our own eyes, running our own experiments, and finding our own answers. So you see, you're not just a learner anymore, you're a young scientist in the making.
So how are we going to do all this? Well, let's go back to that Puri mystery and make it our very first case study. This brings us to Section 2, how to investigate anything. And our big experiment? The Puri experiment, of course. Because remember, science doesn't just happen in a lab, it happens in your kitchen, too.
Now, one of the most important parts of any scientific experiment is something called variables. So what exactly is a variable? It's actually really simple. Variables are just the things we can change in an experiment to see what happens. All the different things we can tweak to check out the effect or the result.
So, in our Puri experiment, what could the variables be? What are the things we can change? Well, as you can see, we could change the thickness of the dough, make it thicker or thinner. We could change the size of the dough, big or small. We could even change the type of flour we use, maybe atta or maida. On top of that, there's the oil temperature and even how we drop the puri into the oil. All of these are our variables.
Okay, so once we've changed one of our variables, we have to note down the result of that change, right? And that's where observation comes in. Observation just means all the things we watch for or measure to see what happened because of our change. Basically, what we notice, what we measure, that's our observation. So, for our Puri, what kind of observations could we make? Let's see. We could note down a bunch of things, like does it puff up? That's a simple yes or no. How long does it take to puff? We can measure that in seconds. And of course, our original question, which side is thinner? We could even watch to see if the oil splatters or if it smells or smokes. All of this is super valuable data for our investigation.
All right, now it's your turn to put on your scientist hat. I've got a question for you. Let's say you want to test how the oil's temperature affects the puree. Which of the other variables must you keep exactly the same? Think about it. I'll give you a few seconds.
And the answer is you have to keep everything else the same. You'd keep the dough thickness, the size, and the type of flour exactly the same. You would only change one thing, the oil temperature. And that, my friends, is the golden rule of any good experiment. Change only one variable at a time. That's the only way you can be sure that whatever result you get is because of that one thing you changed.
Awesome. Now that we know how to investigate in the kitchen, let's zoom out a bit. Way out. Welcome to Section 3, From Purists to Planets. We're about to scale up our investigation. Because the exact same method we just learned, that's what scientists use to solve the biggest mysteries in the entire universe.
For instance, this very same method helps us uncover the hidden world that's teeming with life in just a single drop of water. Scientists use microscopes for observation, and then they change variables, like the temperature or the nutrients in the water, to investigate which tiny microorganisms live there. Some might be helpful, some harmful, but the process, it's exactly the same.
And it's the same scientific thinking that explains things like the heating and magnetic effects of electricity. Scientists investigated questions like, how does an electric iron actually get hot? Or what makes an electric motor spin? By changing variables, like the type of wire or the amount of current, and then carefully observing the heat or the motion that was produced, they uncovered the principles that literally power our world today.
This investigative process is also how we've come to understand fundamental concepts like forces, pressure, and gravity. Just think about the questions that scientists like Isaac Newton asked. Why does a ball always fall down to Earth? Or how do the brakes on a car actually work? They figured out the answers by carefully observing motion and testing variables, and that led to the laws of physics that we still use every single day. And believe it or not, this same kitchen investigation way of thinking helps us understand enormous things, like how changes in air pressure can create powerful cyclones. I mean, think about it. From a puri puffing up because of steam pressure on the inside to a massive storm forming because of air pressure on the outside, the basic method of science, asking a question, identifying variables, and making an observation, is exactly the same. So you see, science isn't just about huge things like cyclones. It's literally all around us in everything we see and touch. So let's explore that in Section 4, the science all around us, looking at particles, light, and time. Because investigation is what reveals the secrets that are hidden right in plain sight.
Here we have a really fundamental idea. Everything, and I mean everything, is made of tiny little particles. Your chair, the water you drink, even the air you're breathing right now. And it's how these particles move that determines if something is a solid, a liquid, or a gas. In a solid, like an ice cube, they're packed together super tightly. In a liquid, like water, they can kind of slide past each other. And in a gas, like the air inside a balloon, they're just flying around freely all over the place.
And check this out. This is a direct link between the sky above and your daily schedule. By observing the moon's cycles, you know, how its shape changes every night, ancient people were able to create the very first calendars. Isn't that amazing? To think that our daily routines right here on Earth are connected to the movements of an object so incredibly far away. Okay, so from the stars, let's bring our investigation back home, back to our planet. This brings us to Section 5, Earth's delicate balance. And this is probably our biggest investigation of all, because right now our planet really needs investigators, more than ever before.
So what makes Earth so special, so perfect for life? Well, it's often called the Goldilocks planet because everything is, well, just right. We're at the perfect distance from the sun, which allows water to exist as a liquid. Our atmosphere gives us the oxygen we need to breathe, and just as importantly, it acts like a giant shield, protecting us from the sun's harmful UV rays.
But here's where we face our biggest challenge. Human activities are starting to upset this delicate balance. They're causing Earth's temperature to rise, which is leading to climate change. Now, this is a massive problem, but science isn't just the tool we use to understand it. Science is also the key to solving it. The very same principles, observing climate data, measuring changes, and experimenting with new technologies are what will help us find solutions to protect this amazing planet we all depend on. So, think about it. We've journeyed from a simple puri all the way to the planets and then back home to Earth. And we've seen how one simple method, investigation, is the key that unlocks everything. Which brings us to our final section, Section 6, your turn to investigate. This whole journey started with one simple question about a puri. Always remember that. Your curiosity is your superpower. So, my final question to you, my fellow young scientist, is this. What's the first question that you want to investigate? Just look around you. Your next great discovery could be waiting for you right in your kitchen, in your backyard, or maybe even up in the stars. Now go find it.